So, good evening, everyone. So, in previous class, we already discussed about preparation and physical properties of aldehydes and as well as ketones. Today we are going to discuss the continued versions of aldehyde ketones and as well as carboxylic acids. So, after completion of physical property of aldehydes and ketones, let's move on to chemical properties of aldehydes and as well as ketones. So let us discuss with the chemical properties. So we already know that there are number of different chemical properties are there in aldehydes and as well as ketones, such as nucleophilic addition reactions, right? The majorly, so they have asked number of questions based on nucleophilic addition reaction. In the same way, so after that, aldol condensation, cross aldol condensation, so many different chemical properties are there. Let us start with the first one, nucleophilic addition reaction. If we consider nucleophilic addition reaction, we already know that. So compulsory, we can choose one particular reaction, whatever the carbonyl groups are there due to this polarity. Polarity, we already know that. So there is a partial double bond will be present between carbon and as well as oxygen. So due to that polarity, so addition of a nucleophile will takes place very easily. If you observe carefully, among carbon and as well as oxygen, oxygen will more electronegative. So that's why all electrons are start moving towards oxygen. Then automatically, so here what happens? They will develop partial negative charge on partial negative. So here the partial negative, that is delta minus, and here partial positive charge on carbon. So we already know that partial positive and negative, this indicates what? So there is a decrease in electron cloud in carbon, there is an increase in electron cloud on oxygen. So due to this polarity, so addition of nucleophile will takes place very easily. If you consider HCN, addition will takes place. So HCN is undergo dissociation as H plus and as well as Cl minus. Here, due to transfer of electron, we are getting negative. So this negative part directly attack on H plus, then the Cn minus will attack on carbon. So then finally we can able to get COH. Here it contains Cn. So definitely we can able to get a cyanohydrin. This is cyanohydrin. So cyanohydrin, either we can consider aldehyde, otherwise in ketones. So whatever it may be the carbonyl compound, when carbonyl compound is reacts with the HCN, addition of HCN will going to take place to form the final compound as cyanohydrin. So in the same way, so if you consider addition of sulfonic acid will also takes place. So in the same way, if you consider for the same carbonyl group C double bond O, due to this polarity, addition of ROH group will takes place. So alcohol, we already know that alcohol. So normally this alcohol should be undergo dissociation. So we can able to get aldehydes, that particular component undergo dissociation. So normally without the ROH is undergo dissociation. So here ROH particular part is undergo dissociation, that is considered as an alcohol. So when this particular component is dissociation, we can able to get RO minus and as well as H plus. So here due to this polarity, we are able to get a minus and as well as plus. Thereafter, H plus will attack here. Then finally, we are able to get a C, single bond O. Here you can be able to get R. Then, so thereafter, here we can able to get O and as well as a H. So here double bond. So then, in the same way, the same component. If we consider same carbonyl group C but double bond O group, when this particular component will undergo reaction with Grignard reagent also RMgX. So here also this one is act as an addition reaction. When RMgX is undergo dissociation, minus and as well as plus. We already know that magnesium is more electropositive element. That's why it can able to donate all the electrons because magnesium is a metal. So thereafter here minus and as well as plus. And so this particular part directly attack here. And finally, that one is undergo hydrolysis. Hydrolysis, we already know that. So CO Mgx, here you can able to get one bond here O and as well as OMGX, OMGX. Thereafter, we can able to attack with an R. So this particular part is undergo hydrolysis. Addition of water molecule will take place. Then after that, here once again it undergo dissociation, and finally, so H plus will directly attach here. Here OH, and here it contain H plus. And the final answer may be C. Here it contain R. Here it contain OH. So in the same way, we already know that whenever formaldehyde, generally we know that when formaldehyde should be reacts with the Grignard reagent RMGX. So the compulsory we can able to get primary alcohol. In the same way, if you observe acetaldehyde, acetaldehyde should be reacts with the Grignard reagent. Definitely we can able to get secondary alcohol. In the same way, acetone, otherwise ketones, when ketone should be reacts with the RMGX, so definitely we can able to get tertiary alcohol. So these are all reaction with the Grignard reagent. And in somewhat, so we can consider one more also. We can take one more example. Ammonia derivatives. This one is also most important one. We already know that whatever the ammonia derivatives are there. So ammonia derivatives are also undergo nucleophilic addition reaction towards a carbonyl compound. So definitely we can able to get different products. So let us discuss how this ammonia derivative reaction will be takes place. So let us discuss one by one. So here ammonia derivative means normally NH3 is an ammonia. So if one hydrogen atom is replaced with any other particular component, so then whatever the compounds we can able to get all are considered as ammonia derivatives. So these ammonia derivatives in the place of an Z, if we consider general reaction, before discussing what is the place of Z here, so just we can consider whatever the carbonyl groups are there here. These carbonyl groups should be reacts with the ammonia derivatives, that is NH2Z. So here what happens? Oxygen and as well as hydrogen both are combined. Removal of water molecule will takes place. Then finally we can able to get the component like this. So this one should be happens only by the removal of water molecules. If you remove water molecules, then only we can able to get this particular product. Let us discuss. This is generalized explanation. So let us discuss what are the different ammonia derivatives are there. So in the place of result, what we are going to use actually. So here NH2Z. If you consider in the place of an Z, if you use NH2, NH2 single bond NH2. So name of this component is called as what? Hydrazine. If you consider another one, NH2OH, in the place of Z, if you use OH, so definitely this one is considered as hydroxylamine. So in the place of Z, if you use NH2, C6H5. So NH2, NHC6H5. If you consider this particular component, that is phenylhydrazine. Phenylhydrazine, and one more important compound. So NH2, here NH. So here you can consider the one benzene structure. So here NO2, here it contain one NO2. So this one is considered as a 2,4 DNP. So name of this compound is called as what? 2,4 dinitrophenyl hydrazine. So in the same way, if you consider one more also, that is NH2, in the place of an Z, we can use NHC double bond O NH2. So here name of this compound is also called as semi-carbazide. So these very number of ammonia derivatives are there. So let us discuss how this reaction will be takes place. Already we know that according to general reaction, so here removal of water molecule will takes place. So after removal of a water molecule, definitely they are able to get different product. Let us discuss what are those important product and how we can able to form it. So here the NH2 and as well NH2 hydrazine so undergo the particular reaction. If we consider here, if we consider hydrazine, when this one is undergo reaction with the carbonyl compound C double bond O group, then automatically what happens? So we can able to get one product as C double bond removal of water molecule will takes place. Then finally we can able to get the compound as oxime. So name of this compound is called as what? Oxime. So in the same way, when the same component that is hydrazine, so that is reacts with the carbonyl compound, then finally we can able to get NH2. So name of this compound is called as a hydrazone. So like that, in the same way, if you use phenyl hydrazine, when it is reacts with carbonyl compounds, aldehyde otherwise ketone, definitely we can able to get a phenyl hydrazone. So when this one should be reacts with 2,4 DNP, here removal of water molecule will takes place. This hydrogen is completely removed. Here also same. This hydrogen is removed. So be careful. So phenyl hydrazine C6H5 benzene ikkada iro NH2 e hydrogen remove agutte. And here also same NH2 and here also it contain NH2 in the semi carbazide. So definitely we are getting confusion where we are going to remove two hydrogen atoms. So observe ಮಾಡಿದ್ರೆ NH2 NH ಏನಿದೆಯೋ ಆ particular part ಅಲ್ಲಿ ಏನ್ ಮಾಡಬೇಕು, we have to remove two hydrogen atom. So ಇಲ್ಲಿ single ಇರೋ NH2 ದಲ್ಲಿ remove ಮಾಡಂಗಿಲ್ಲ, ಗೊತ್ತಾಗ್ತಿದೆಯಾ? Here we can able to remove it. So semi-carbazone we can able to get here 2,4 dinitrophenyl hydrazone. So here phenyl hydrazone, then hydroxylamine. So ಇಲ್ಲಿ hydroxylamine ಏನಿದೆಯೋ we can able to get an oxime. Finally hydrazine, here we can able to get a hydrazone. So like that different compounds we can able to get it when carbonyl compound should be reacts with what we call nucleophilic addition reactions. So here after completion of these particular components, next to move on to the most important one, reduction reaction. Let us start with the reduction reaction. I think there are different reagents are there where reduction reaction will takes place. So like lithium, aluminum hydride, sodium borohydride, nickel, platinum and palladium, so many different reagents are there. Let us discuss how this reagent helpful to reduce carbonyl compounds. So normally if we consider one component, we can use whatever the carbonyl groups are there here, that is CH3, C double bond O, CH3. Either it may be considered as aldehyde, otherwise in ketones, when this should be addition of hydrogen will takes place. So in the presence of nickel, platinum and as well as palladium, so these are all act as strong reducing agents. So we already know that addition of hydrogen will takes place here. If you break one bond, we can add up two hydrogen atoms. So then finally, we can able to get CH3, C, here it contain OH and here CH and as well as CH3. So when ketone, if you observe, when ketone is undergo reduction in the presence of nickel, platinum and as well as palladium, so compulsory we can able to get secondary alcohols. So in the same way, if you consider acetaldehyde also, CH3, C double bond O, H, when this one is undergo reduction in the presence of the same nickel, platinum, otherwise palladium. So here, if you observe, same pi bond is undergo breakage. Instead of one bond, we can add two hydrogen atom. So CH3, C, H2, OH. So name of this particular component is called as ethanol. That is a primary alcohol. When aldehyde is undergo reduction, definitely we can able to get primary alcohol. When ketone should be reacts undergo reduction to form a secondary alcohol. In the same way, when formaldehyde, if you use formaldehyde, ನಾವೆಲ್ಲಾದ್ರೂ ಕೂಡ formaldehyde use ಮಾಡಿದ್ರೆ, formaldehyde also undergo reduction. So compulsory it form methanol. Over. So then after that, if you consider reduction onwards, so another different reducing agent we have to use it. That is a lithium aluminum hydride. Otherwise, we can consider sodium borohydride. So another reducing agents we can use here: lithium aluminum hydride, LH. Otherwise we can use a sodium borohydride also. So here, compared to lithium aluminum hydride and as well as sodium borohydride, so among these, lithium aluminum hydride will be a strong reducing agent. So what is the use of this lithium aluminum hydride? This one act as a strong reducing agent. So, but compared to lithium aluminum hydride, sodium borohydride is a mild reducing agent. Then let us discuss what is the use of this lithium aluminum hydride and as well as sodium borohydride. So compulsory what happens, whatever the aldehyde otherwise ketones are there, these aldehyde and ketones should be undergo reduction to form a respective alcohols. We can consider either we can use lithium aluminum hydride, otherwise what? Sodium borohydride. So compulsory what happens? They can easily converted into an alcohol. Same thing, breaking a bond will take place. So finally ಏನ್ ಬರುತ್ತೆ CH3 ಇದೆ ಇಲ್ಲಿ C H, here it contain OH and here it contains CH3. Here also same secondary alcohol. So lithium aluminum hydride. So normally what happens, whatever the lithium aluminum hydrides are there that can having capacity to convert a cyanide into amine also. Cyanide and amine reduce mada capacity kuda ide yavudike lithium aluminum. Sodium borohydride is a selective reducing agent, right? So but when it comes under another reactions like Clemmensen reduction, Clemmensen reduction. So we already know that we can use a certain reagents for Clemmensen reduction. So normally the reagent what we are going to use, the reagents are mentioned as a zinc amalgam. So amalgam indicates what? Mercury, zinc amalgam with an HCl, hydrochloric acid. When we are using zinc amalgam with an HCl, so automatically what happens? Aldehydes and ketones should be converted into what? Hydrocarbons. The major issue is just we are converting a C double bond, a carbonyl group into CH2 hydrocarbons. So removal of this hydrogen will completely take place. Nodappa, oxygen completely removed and addition of hydrogen atom will take place. So addition of hydrogen is considered as what? Reduction. In the same way, another one, Wolff-Kishner reaction. If you consider Wolff-Kishner reduction, normally hydrazine, we can use the reagent for Wolff-Kishner reaction is hydrazine NH2 single bond NH2, and this one is undergo further hydrolysis. So we can able to convert C double bond O carbonyl group into hydrocarbons. So let us discuss how this one can be converted into hydrocarbons. We already know that C double bond O, when this compound should be reacts with NH2 single bond NH2. So same thing, nucleophilic addition reaction, water molecule is removed. So hydrazone we can able to get N, here NH2. So when this one is undergo hydrolysis, so finally it is possible to get the component as the component what we are observing, that is hydrocarbons. So after hydrolysis, we can able to get final component. So this is about Clemmensen reduction and as well as Wolff-Christian reduction. So and here one small information is there in Clemmensen reduction as well as Wolff-Christian. In Wolff-Christian, what happens if any OH groups are there particularly? So in Wolff-Christian, if any OH groups are there, definitely they undergo what? A dehydration. So in the presence of zinc, so in the presence of what? Hydrogen. But in the same way, in Clemmensen reduction, what happens? If they contain halogen, definitely what happens? They undergo what? A dehydrohalogenation. So this is another information regarding Clemmensen as well as Wolff-Christian. Suppose I will give one example here. So CH3, CH. So here it contains Cl, here it contains CH2, here it contains C double bond O CH3. When this particular component should be reacts with zinc amalgam and as well as HCl. If you observe now, zinc amalgam, already we know that if it contain any halogen atom, automatically what happens in Clemmensen reduction, that one is undergo dehydrohalogenation. Dehydrohalogenation means that is also called as beta elimination. So here, according to an of rule, we can able to remove hydrogen atom here only, and the final product what we are observing, CH3, C H double bond CH, here it contain CH2 CH3. Now this one is converted into what? Undergo reduction, addition of hydrogen will take place, and this one is undergo what? Dehydrohalogenation. So this is all about Wolff-Christian reduction and as well as Clemmensen reduction. So after discussing Wolff-Christian and as well as Clemmensen, so next move on to another important concept, oxidation. So oxidation of aldehydes and as well as ketones. So if we consider oxidation of aldehydes and as well as ketones, so normally we know that by using a strong oxidizing agent, strong oxidizing agent na use ಮಾಡಿದ್ರೆ, so already now discuss ಮಾಡಿದ್ವಿ what are those strong oxidizing agents are then. So strong oxidizing agents ಅಂದ್ರೆ ಯಾವುದು? Acidic KMnO4 and as well as acidic K2Cr2OCN. These are all act as a strong oxidizing agent. They can convert aldehyde into what? Carboxylic acids. So strong oxidizing agent, same thing, CH3, CH2, C double bond O H. When this particular component should be reacts with undergo oxidation in the presence of K2Cr2O7, acidic K2Cr2O7. So compulsory what happens? Addition of oxygen will take place, and finally, so we can able to get CH3, CH2, C double bond O OH. So name of this compound 1, 2, 3. So name of this compound is called as propanoic acid. Propanoic acid. Otherwise, either we can use a KMNO4, acidic KMNO4. So acidic KMNO4 is also one of the strong oxidizing agent which is able to convert aldehydes into what? Carboxylic acids. And like that, we can consider same example CH3C double bond OH. Then we go to the addition of oxygen will take place in the presence of strong oxidizing agent as KMNO4H plus. Observe ಮಾಡಪ್ಪ ಇಲ್ಲಿಗೆ ಆಕ್ಸಿಜನ್ ಅಡಿಷನ್ ಮಾಡಿದ್ರೆ, so finally we are able to get a CH3 C double bond O OH. So name of this compound is called as ethanoic acid. Ethanoic acid ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ. So ಅದೇ ಆದ್ಮೇಲೆ ಕಡೆಗೆ, so here the oxidation of ketone will be different. So aldehyde, normally what happens? Aldehydes can easily undergo reduction. We can easily identify product also. But when ketone is undergo oxidation, then the identification of product is completely depend on one particular rule. That rule is also called as a Popov rule. So according to this Popov rule, so we came to know that how we can able to identify the product, the final product, when ketones are undergo reduction. So here what happens, if we consider symmetrical ketones and as well as unsymmetrical ketones, symmetrical means CH3, C double bond O, CH3. If you observe now, the carbonyl group contain similar number of carbon atom both the side, definitely that is considered what? Symmetrical ketones. So when symmetrical ketones are there, then identification of product is very easy. So when this one is undergo oxidation in the presence of KMNO4, strong oxidizing agent in acidic media, then automatically what happens? A breaking of bond will takes place here. So after breaking of a bond, so here the compulsory, so we can able to get two products, that is CH3 COOH. Here this one is converted into CH3 COH, and this one is mentioned as carbon dioxide and as well as water. CH3 should be converted into carbon dioxide and as well as water. In the same way, if you observe CH3 C double bond O CH2 CH3. So if you observe this particular component, here what happens? Here it contains one carbon atom, but here it contains two carbon atom on either side of an aldehyde group. So if you observe now, a maximum number, one side it contain maximum number of carbon atom, another side it contain what? A lesser number of carbon atom. So according to Popov rule, so the ketonic group will be stay on those particular side where it contain a less number of carbon atom. So that is considered as what? Popov rule. If you observe now, here it contain less number of carbon atom, here it contain a maximum number of carbon atom. So that's why breaking will take place here. This ketonic group will be present in that particular side. It contain lesser number of carbon atom. Then the final answer would be in the presence of same KMNO4 and as well as H plus. ಈಗ ಅಬ್ಸರ್ವ್ ಮಾಡಿ ನೋಡಪ್ಪ, CH3 COOH and one more CH3 COOH ಬರುತ್ತೆ. ಇಲ್ಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿ ನೋಡ್ರಿ, CH3 CH2 ಇದೆ ಇಲ್ಲಿ. So this one is converted into carboxylic acid group COH. Here already it contain one carbonyl group. So for this carbonyl group, addition of OH group is takes place. Addition of oxygen atom ಆಗಿ ಇದು CH3 COH, ಇದು ಕೂಡ ಏನಾಗುತ್ತೆ CH3 COH. ನೋಡೋಣ, ಇನ್ನೊಂದು ಎಕ್ಸಾಂಪಲ್ ಕೊಟ್ರೆ ಯಾವ ರೀತಿ ನೀನು ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀಯ Popov rule ಅಂತ ಹೇಳಿ. First we can consider one more example, CH3. So another one CH3 CH2 CH2. Here it contains C double bond O, here it contains CH2 CH3. ನೋಡಪ್ಪ, when this one is undergo oxidation in the presence of strong radio oxidizing agent like KMNO4 otherwise K2Cr2O7. So here it contains 3 carbon atoms, here it contains only 2 carbon atoms. According to Popov rule, ketone will be stay in those particular side which contain a less number of carbon. So here breaking of bond will take place here. Then finally the answer will be CH3 CH2 COOH. Another component may be CH3 CH2 COOH. So this is the oxidation of what? Ketone. So then after discussing the oxidation of ketone, how this one will be takes place. Next move on to one more important reaction, that is also called as iodoform reaction. So in iodoform reaction, compulsory we have to use a reagent. ನೋಡು, ಯಾವುದೇ ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ ನೀನು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕಂದ್ರೆ ಫಸ್ಟ್ ನೀನು ತಿಳ್ಕೊಬೇಕಾಗಿರೋದು ರಿಯೇಜೆಂಟ್ ಏನು, ಆ ರಿಯೇಜೆಂಟ್ ಏನ್ ಕೆಲಸ ಮಾಡುತ್ತೆ ಅಂತ ತಿಳ್ಕೋಬೇಕು. ಸೊ ಇಫ್ ಯು ಅಬ್ಸರ್ವ್ ಕೇರ್ಫುಲಿ ವಾಟ್ ಆರ್ ದೋಸ್ ರಿಯೇಜೆಂಟ್ ಅಂಡ್ ಹೌ ದೇ ವಿಲ್ ವರ್ಕ್ ಆನ್ ವಿತ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಪೊಸಿಷನ್, ಸೊ ಡೆಫಿನೆಟ್ಲಿ ವಿ ಕ್ಯಾನ್ ಈಸಿಲಿ ರೈಟ್ ಅ ಫೈನಲ್ ಪ್ರಾಡಕ್ಟ್. ರಿಯೇಜೆಂಟ್ ಅಂದ್ರೆ ಯಾವ್ದು ಯೂಸ್ ಮಾಡ್ತೀವಪ್ಪ ಇಲ್ಲಿ? ಸೋಡಿಯಂ ಹೈಡ್ರಾಕ್ಸೈಡ್ ಇನ್ ದ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ಬ್ರೋಮಿನ್. ನೋಡು, ಇಫ್ ಯು ಆಡ್ ಬ್ರೋಮಿನ್, ಸೊ ನೆಕ್ಸ್ಟ್ ಡೆಫಿನೆಟ್ಲಿ ನಮಗೆ ಏನ್ ಬರುತ್ತೆ? ಬ್ರೋಮೋಫಾರ್ಮ್ ಬರುತ್ತೆ. ಇಲ್ಲಿ ನಾನು ಮೆನ್ಷನ್ ಮಾಡಿರೋದು ಏನಪ್ಪಾ ಅಂದ್ರೆ ಅಯೋಡೋಫಾರ್ಮ್ ಅಂತ ಮೆನ್ಷನ್ ಮಾಡಿದ್ದೀನಿ. ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ಯೂಸಿಂಗ್ Br2, we can use I2 ನ ಯೂಸ್ ಮಾಡೋಣ, sodium hydroxide, and the combination of these two, so we can able to produce NaOI, sodium. So when this particular component should be reacts with those particular carbonyl compounds, they contain methyl group. That methyl should be directly at carbonyl. ನೋಡು, iodoform reaction ಆಗ್ಬೇಕಂದ್ರೆ, to undergo iodoform reaction compulsory the carbonyl group should contain at least one CH3 group. Without CH3 group, otherwise without methyl group, there is no iodoform reaction. We can take one example also, CH3. So C double bond O R. So here we can consider one CH3 group. When this particular component should be reacts with NaOI. So then finally, here what happens? So this one is undergo iodoform. So finally, we can able to produce a CHI3 and one more component. This one is converted into what? Sodium salts of carboxylic acid. That is a RCOO. So this particular reaction is called as what? Iodoform reaction. Normally, this reaction is used to identify whether the given aldehyde otherwise ketones which contain a methyl group or not. If it contain methyl group, so then only they undergo what? Iodoform. So otherwise, we can take one more example also. So ಇನ್ನೊಂದು example ತಗೋಣ CH3, CH2, C double bond O, CH2, here CH3. So normally if you observe this particular component, this component is never undergo iodoform reaction because the carbonyl group does not contain any methyl group. If it contain methyl group, then only the one is undergo what? Iodoform reaction. So then after completion of this iodoform reaction, let's move on to aldol condensation. Aldol condensation. If you observe now aldol condensation, so aldol condensation should be carried out in those aldehyde otherwise ketones. So they contain alpha hydrogen atom. Without a alpha hydrogen atom, there is no aldol condensation. So compulsory ಏನಾಗಬೇಕಂದ್ರೆ ಅಲ್ಲಿ aldol condensation ಆಗಬೇಕಂದ್ರೆ compulsory ಏನ್ ಬೇಕು ನಮಗೆ alpha hydrogen is very important. So alpha hydrogen, let us know what do you mean by that alpha hydrogen atom. Here CH3, C double bond O, ಇಲ್ಲೊಂದು ಏನ್ ಬರುತ್ತಪ್ಪ CH3. ಈಗ ಅಬ್ಸರ್ವ್ ಮಾಡು, this is carbon, otherwise this is functional group. Functional group containing carbon is called as alpha. Functional group containing carbon is called as what? Alpha. So ಈ alpha carbon ಅಲ್ಲಿ ಕಂಪಲ್ಸರಿ ಏನಾಗಿರ್ಬೇಕು ಅಂದ್ರೆ hydrogen. So without alpha hydrogen atom, there is no aldol condensation. So let us know why it is called as aldol and as well as condensation. So aldol condensation anta ಯಾಕೆ ಕರಿಬೇಕು? It contain otherwise sometimes that one is also considered as what? Ketol also, right? So aldol condensation should be carried out either by using same aldehyde, otherwise we can use same ketone, same aldehydes and as well as ketones that should be reacts with what? Sodium hydroxide. When they react with sodium hydroxide, then only they undergo what? Aldol. So this obtained compound is undergo heated at high temperature. They undergo condensation. Condensation is nothing but what? Removal of water molecules. Water molecule remove ಆಗುತ್ತೆ. So ಹೇಗಾಗುತ್ತೆ aldol condensation ಯಾವ ರೀತಿ ಐಡೆಂಟಿಫೈ ಮಾಡಬೇಕು? Of course, so many students they are facing difficulty to understand how we can able to write aldol condensation. So mechanism ಎಲ್ಲ ತಿಳ್ಕೋಬೇಕಂದ್ರೆ ಸ್ವಲ್ಪ ತಲೆನೋವು ಅಂತ. So but I will give an easiest way to write aldol condensation, that is CH3, C double bond O, CH3. Of course, we can consider one acetaldehyde better, not acetone. We can consider acetaldehyde. ನೋಡು ಸೇಮ್ ಟೈಪ್ ಆಫ್ ಆಲ್ಡಿಹೈಡ್ ಅಂಡ್ ಸೇಮ್ ಟೈಪ್ ಆಫ್ ಕೀಟೋನ್ ತಗೋಬೇಕು. ಈಗ ನಾನು ಅಸಿಟಾಲ್ಡಿಹೈಡ್ ತಗೊಂಡಿದ್ದೀನಿ ಅಂತಂದ್ರೆ ಕಂಪಲ್ಸರಿ ಇನ್ನೊಂದು ಕೂಡ ಏನಾಗಿರ್ಬೇಕು? ಅಸಿಟಾಲ್ಡಿಹೈಡ್. ಹಿಯರ್ ವಿ ಕ್ಯಾನ್ ಚೂಸ್ ಟೂ ಅಸಿಟಾಲ್ಡಿಹೈಡ್ಸ್. ಒಂದು ಅಸಿಟಾಲ್ಡಿಹೈಡ್ ಏನ್ ಮಾಡ್ಬೇಕು ಅಂತಂದ್ರೆ ಸಿ ಡಬಲ್ ಬಾಂಡ್ ಓ ಗ್ರೂಪ್ ನ ಓಪನ್ ಬರ್ಕೋಣ. So we can take another acetaldehyde. In another acetaldehyde, what happens here? We can write here alpha hydrogen atom as a open. Alpha hydrogen atom open ಮಾಡ್ಕೊಂಡೆ ಅಂದ್ರೆ ನಮಗೆ ಸೊ ಶಿಫ್ಟಿಂಗ್ ಆಫ್ ಆಟಮ್ಸ್ ಯಾವ ರೀತಿ ಆಗುತ್ತೆ ಅಂತ ಹೇಳಕ್ಕೆ ಈಸಿ ಆಗುತ್ತೆ. ಈಗ ಅಬ್ಸರ್ವ್ ಮಾಡು. ಸೊ ಡ್ಯೂ ಟು ದಿಸ್ ಪೊಲಾರಿಟಿ ವಿಲ್ ಡೆವಲಪ್ negative and as well as positive. So here this one is undergo dissociation as H plus and as well as carbon will get minus. Oxygen directly attack on H plus and this particular carbon will attack on another carbon atom. It contain positive charge. So now CH3. So another one C, here hydrogen. So for this particular component here O will be there actually. For O we are adding hydrogen. So thereafter single bond CH2 CHO. So this particular compound is called as what? Aldol. So why it is called as aldol? Because it contains aldehyde and as well as alcoholic group. So when this particular aldol is undergo condensation by increasing a temperature, so definitely we can able to get alpha beta unsaturated aldehydes, otherwise as ketones. But here we can able to get aldehydes. So sometimes we can able to get ketone also. So ಯಾವ ರೀತಿ ಆಗುತ್ತಪ್ಪ? So observe ಮಾಡೋಣ ಇಲ್ಲಿ. So here we can write one more hydrogen separately. So here this one is removed as H plus, and here we can remove as OH minus. So to satisfy the valency, this bond is shifted to here, and finally ಏನ್ ಬರುತ್ತಪ್ಪ CH3 CH bond shift ಆಗಿದೆ double bond CH, here it contain what CHO. So this one is considered as alpha beta unsaturated aldehydes. This one is considered as aldol condensation. So not only we can consider aldol condensation for acetaldehyde, we can choose one more ketone also. ಸೊ ಕೀಟೋನ್ ಅಷ್ಟೇ, ಕೀಟೋನು ಕೂಡ ಏನಾಗುತ್ತೆ, ಒಂದು ಕಾಂಪೋನೆಂಟ್ ಅಲ್ಲಿ ಸಿ ಡಬಲ್ ಬಾಂಡ್ ಓಪನ್ ಬರ್ಕೊಡ್ರಪ್ಪ CH3. ಸೊ ಇನ್ನೊಂದ್ರಲ್ಲಿ ಏನ್ ಮಾಡೋಣ, ಹೈಡ್ರೋಜನ್ ಒಂದು ಆಲ್ಫಾ ಹೈಡ್ರೋಜನ್ ಓಪನ್ ಬರ್ಕೋಣ. ಸೊ ಹಿಯರ್ ವಿ ಕ್ಯಾನ್ ಕನ್ಸಿಡರ್ COCH3. ವೆನ್ ದಿಸ್ ಕಾಂಪೋನೆಂಟ್ ಶುಡ್ ಬಿ ರಿಯಾಕ್ಟ್ ವಿತ್ ಸೋಡಿಯಂ ಹೈಡ್ರಾಕ್ಸೈಡ್ NaOH ರಿಯಾಕ್ಟ್ ಆದ್ರೆ ಸೇಮ್ H ಪ್ಲಸ್ ಅಯಾನು ಇಲ್ಲಿ ಏನಾಗುತ್ತಪ್ಪ ಅಂದ್ರೆ, ಸೊ ಮೈನಸ್ ಇಲ್ಲಿ ಪ್ಲಸ್ ಆಯ್ತು ಅಂತಂದ್ರೆ ದಿಸ್ ಬಾಂಡ್ ಇಸ್ ಶಿಫ್ಟೆಡ್ ಟು ಹಿಯರ್, ದೆನ್ ಅಗೈನ್ CH3 C, here it contain one CH3. ಇಲ್ಲಿ ಏನ್ ಬರುತ್ತೆ, ಓಗೆ ಹೆಚ್ ಅಡ್ ಹೆಚ್ ಆಗುತ್ತೆ, ಹೌದಾ? ಸೊ ಇಲ್ಲೇನ್ ಬರುದಮ್ಮ, ಸೊ ಸಿ ಹೈಡ್ರೋಜನ್, ಹಿಯರ್ ಒನ್ H, ಹಿಯರ್ ಇಟ್ ಕಂಟೈನ್ COCH3. So water molecule after reacts heated with high temperature, removal of water molecule will takes place. This bond is shifted to here, and final answer is CH3 C, CH3 double bond CH single bond CO CH3. ಅರ್ಥ ಆಗ್ತಿದೆ ಅಂತ ಅನ್ಕೊಳ್ತೀನಿ. So in this particular component what happens, here also same we can able to get alpha beta unsaturated acids and unsaturated ketones. Next if you observe this particular component formaldehyde HCHO, so this formaldehyde so never undergo aldol condensation. So when the same component should be reacts with NaOH, so this one is never undergo aldol condensation. Why? Because so here this particular component does not contain any alpha hydrogen atom. Without alpha hydrogen atom there is no aldol condensation. So if it does not contain an alpha hydrogen atom, compulsory to undergo Cannizzaro reaction. So Cannizzaro reaction when aldehydes and ketones without containing alpha hydrogen atom reacts with an alkalis. So compulsory it produces alcohol and as well as respective sodium salts of carboxylic acids. So here we can consider HCOO Na, and another one is we can consider CH3OH. In the same way, here also same benzaldehyde, also same component. This benzaldehyde, never contain alpha hydrogen atom, and this one is also reacts with the alkali, and 100% sure this one is undergo aldol condensation. So we can able to get same component CH2OH benzyl alcohol, and another one sodium salt of benzoic acid. Here we can able to produce COON with alpha hydrogen atom and without alpha hydrogen atom. So then after discussing aldol condensation and as well as Cannizzaro reaction, next move on to one more important thing is cross aldol condensation. Of course we already know that. So here what happens, if we choose same aldehydes or by same ketones, definitely they undergo what aldol condensation reaction. But if they undergo, if we are taken two different aldehydes, otherwise two different ketones, or one aldehyde otherwise ketones, so definitely it is possible to get more than one product. So that the reaction is called as what, a cross aldol condensation. Let's discuss how this cross aldol condensation should be carried out. So if you can consider CH3 C double bond OH, when this should be reacts with the CH3 C double bond O CH3. Here two possibilities are there. Either we can use alpha hydrogen atom of this particular methyl group, either we can use alpha hydrogen of this particular component. ಅರ್ಥ ಆಗ್ತಿದೆಯಾ? ಸೊ ಇದರಲ್ಲಿ ಒಂದು ಪ್ರಾಡಕ್ಟ್ ಬರುತ್ತೆ, ಅದಕ್ಕೊಂದು ಪ್ರಾಡಕ್ಟ್ ಬರುತ್ತೆ. So one time we are able to get alpha beta unsaturated aldehyde, in another time we are able to get alpha beta unsaturated ketones. So we can take this one as an example. If you observe now, ಇಲ್ಲೇನ್ ಬರುತ್ತಪ್ಪ, CH2 ಇದೆ, ಇಲ್ಲೊಂದು ಹೈಡ್ರೋಜನ್ ಇದೆ, ಇಲ್ಲಿ H ಪ್ಲಸ್ ಹಾಕಿದ್ವಿ, ಬಾಂಡ್ ಶಿಫ್ಟ್ ಮಾಡಿದ್ವಿ, ಮೈನಸ್ ಅಂಡ್ ಆಸ್ ವೆಲ್ ಆಸ್ ಪ್ಲಸ್. ಇದಕ್ಕೆ ಏನಾಗುತ್ತೆ H ಪ್ಲಸ್, ಇದು ಡೈರೆಕ್ಟ್ ಆಗಿ ಇಲ್ಲಿಗೆ ಅಟ್ಯಾಕ್ ಆಗುತ್ತೆ. ಸೊ ಅಲ್ಲಿಗೆ ಏನಾಗುತ್ತೆ ರಿಯಾಕ್ಷನ್ ಸೇಮ್ ಕಾಂಪೋನೆಂಟ್ CH3 ಇದೆ. CH3 C ಹಿಯರ್ ಇಟ್ ಕಂಟೈನ್ OH, ಇಲ್ಲೊಂದು ಹೈಡ್ರೋಜನ್ ಹಿಯರ್ CH2. ಸೊ ದೇರ್ ಆಫ್ಟರ್ C double bond O, C double bond O, CH3, C double bond O, CH3 here after reduction. So removal of water molecule will takes place. So then finally CH3, CH double bond CH, CO, CH3. So in the same way, if you take on reverse order, aldehyde alpha hydrogen atom which is present in aldehyde and the carbonyl group which is present in ketones. So another component we can able to get here, that is a CH3. So otherwise we can write here separately. CH3, C double bond O, here it contains CH3. When this one should be reacts with the CH2, here it contain hydrogen, CHO ಅಂತ consider ಮಾಡಿದ್ರೆ ಇದಕ್ಕೆ ನಾವು ಆಲ್ಕಲಿ ಹಾಕಿದ್ರೆ NaOH. So after that what happens? So same thing. So in ಬರ್ತಪ್ಪ CH3, C here it contains CH3, here OH single bond CH2, CHO. So ಅದರಲ್ಲಿ ವಾಟರ್ ಮಾಲಿಕ್ಯೂಲ್ ರಿಮೂವ್ ಆದ್ರೆ ಏನ್ ಬರುತ್ತೆ ಹೀಟ್ ಮಾಡಿದಾಗ CH3, C double bond, here it contains CH3, CH. So if we observe now, here we can able to get aldehyde, alpha beta unsaturated aldehyde. In previous case we are able to get alpha beta unsaturated ketones. So here two possibilities are there. So if you use different alpha hydrogen atom, the obtained products are different, that is cross aldol condensation. So then after discussing aldol condensation and as well as cross aldol condensation, so next move on to another most important thing is halogenation and nitration. So electrophilic addition reaction. So how this electrophilic addition reaction will take place in halogenation and as well as nitration. So normally in electrophilic addition reaction, whatever the aldehydes are there, especially if we consider benzaldehyde. So benzaldehyde, the particular group, this particular group is meta-directing group. Meta-directing group for electrophilic substitution reaction. Electrophilic substitution reaction. So why? Because whatever the CHO groups are there, benzaldehyde, the CHO group is electron withdrawing group. So electron withdrawing group means compulsory we can able to produce minus M effect. Due to that minus M effect, they can produce electron deficient center on ortho and as well as a para position. So here electron rich center will be there in meta position, electrophile will directly attack on meta position. So either we can consider nitration, either we can consider sulfonation, nitration and as well as sulfonation. So nitration and as well as sulfonation especially. So both will attack on meta position. So because this group is act as meta directing group. So meta position attack agate. For example, if we consider benzaldehyde, so if we consider benzaldehyde when concentrated HNO3 and as well as concentrated H2SO4, both are added. Then finally, nitro group is attack on meta position because that is a meta directing group, strong meta directing group. Over. So this is all about electrophilic substitution reactions. So after discussing electrophilic substitution reaction, both nitration and as well as sulfonation. So next, move on to one more important concept, that is carboxylic acids. Move on to carboxylic acids. So carboxylic acids also contain a carbonyl group, that is C double bond O group. So no need to explain once again the IUPAC nomenclature. Already we know that. So IUPAC nomenclature. So here we can consider CH3COOH. Name of this compound is also called as acetic acid. So and another one CH3, CH2, COOH, propionic acid. Common name of this particular compound is propionic acid. Another one CH3, CH2, CH2, COOH. Name of this compound is called as butyric acid. Why it is called as a butyric acid? Because it is extracted from rancid butter. So that's why, according to Greek word, butyr is nothing but a rancid butter. That's why it can able to extract it. So then, so after knowing IUPAC nomenclature, some of the common name regarding carboxylic acid. Next, move on to preparations. Preparation of carboxylic acid. There are different number of methods are there. We can able to prepare carboxylic acids. So here the so first one is the major important one, oxidation. So oxidation of aldehyde and as well as ketones. We can consider RC double bond OH. Then this one should be undergo oxidation in the presence of strong oxidizing agent KMnO4 in an acidic media. So finally it is converted into RC double bond OH, carboxylic acid barutte. Carboxylic acid, aldehyde. So compulsory undergo reduction, we give carboxylic acid in the same way by applying a Popov rule also. So ketones are undergo oxidation, definitely they can able to produce carboxylic acid. I think no need to explain once again how the reaction will takes place. So when addition of the component will takes place, then finally CH3, COOH and carbon dioxide and as well as what. So this is one method of preparation of carboxylic acid. So another method of preparation of carboxylic acid we can use by using alkyl benzene. So when this alkyl benzene should be reacts with KMnO4 act as a strong reducing agent. So KMnO4 is the reactor directly it converts side chain into COH group. Side chain and ena convert ಮಾಡುತ್ತೆ. The side chain should be converted into what? A COOH group. So sometimes what happen, not only we can use acidic KMnO4, we can also use alkaline KMnO4. When alkaline KMnO4 is also used here, they can also having ability to convert a side chain into a carboxylic group. Let us discuss how we are using alkaline KMnO4. So ಹೇಗಿರುತ್ತೆ ಯೂಸ್ ಮಾಡಬೇಕು ಸೇಮ್ ಕಾಂಪೋನೆಂಟ್ ಸೊ ಸೇಮ್ ಮಿಥೈಲ್ ಗ್ರೂಪ್ ಈ ಮಿಥೈಲ್ ಗ್ರೂಪ್ ಏನಾಗುತ್ತೆ ಸೊ ವಿ ಕ್ಯಾನ್ ಯೂಸ್ KMnO4 alkaline KMnO4 we can use KOH also, otherwise we can use NaOH. ಬೇಕಾದ್ರೆ NaOH ಯೂಸ್ ಮಾಡೋಣ, ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ. So alkaline KMnO4 ಯೂಸ್ ಮಾಡಿದ್ರೆ this one is should be converted into what? COONA. Then this one is undergo further hydrolysis. It produce benzoic acid. ಏನ್ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡುತ್ತೆ ನಮಗೆ ಬೆನ್ಸೋಯಿಕ್ ಆಸಿಡ್ ಪ್ರೊಡಕ್ಷನ್ ಮಾಡುತ್ತೆ. ಸೊ ದಿಸ್ ಇಸ್ ಅನ್ ಅನದರ್ ಮೆಥಡ್. ಸೊ ಆಲ್ಕಲಿನ್ KMnO4 ನ ಯೂಸ್ ಮಾಡಿದ್ರೆ ಕಂಪಲ್ಸರಿ ಏನಾಗೋದಪ್ಪ ಅಂದ್ರೆ ಸೊ ವಾಟ್ ಎವರ್ ದಿ ಸೈಡ್ ಚೈನ್ಸ್ ಆರ್ ದೇರ್ ಹಿಯರ್, ಸೈಡ್ ಚೈನ್ ಶುಡ್ ಬಿ ಕನ್ವರ್ಟೆಡ್ ಇಂಟು ವಾಟ್? Side chain is undergo oxidation and finally it is converted into carboxylic acid. So not only this, if you use large number of carbon atoms are there in side chain, even though they contain maximum number of carbon atom, so here so compulsory in the presence of alkaline KMnO4, what happens here? Directly they should be converted into benzoic acid, that is COONA, and further hydrolysis H3O plus it is converted into benzoic acid. COOH ಆಗಿ convert ಆಗುತ್ತೆ COH over. Next if you use so another one is another method of preparation of carboxylic acid. So normally we can use a Grignard reagent also. When we use RMGX Grignard reagent, this should be reacts with carboxylic acid. ನಿಮ್ಗೆ ಗೊತ್ತೇ ಇದೆ, ಇಲ್ಲೂ ಕೂಡ ಏನಾಗುತ್ತಪ್ಪ ಅಂದ್ರೆ ಚಾರ್ಜ್ ಸಪರೇಷನ್ ವಿಲ್ ಟೇಕ್ಸ್ ಪ್ಲೇಸ್. ಸೊ ಪ್ಲಸ್ ಇರೋದು ಇಲ್ಲಿ ಕಡೆಗೆ ಆಗುತ್ತೆ, ಸೊ ಮೈನಸ್ ಇರೋದು ಇಲ್ಲಿ ಕಡೆಗೆ ಆಗುತ್ತೆ. ಸೊ ಅಲ್ಲಿಗೆ ಏನಾಯ್ತು, ಸಿ ಇದೆ, ಡಬಲ್ ಬಾಂಡ್ ಓ ಇದೆ, ಯೋರ್ ಆರ್ when should be undergo hydrolysis, addition of water molecule will take place. But again bond break ಆಗುತ್ತೆ. So finally it produces R C double bond O OH carboxylic acid ಬರುತ್ತೆ. Carboxylic acid. In the same way, if you consider one more, CH3 Mg Br, when this one should be reacts with carboxylic acid. So finally, it can able to produce CS3COH. So on further hydrolysis, right? So this is all about certain preparation regarding carboxylic acid. So in next class, so definitely we'll discuss about so acidic